Dear students, I have come with a new module, calculation of correlation coefficient when change of scale and origin is made. So this is an important property of correlation coefficient, and I am going to explain in this module with the help of two problems how this can be a merit for the correlation coefficient. Now, important property of Pearsonian coefficient, that is, Pearsonian coefficient is independent of change of scale and origin of x and y variables. That is what I want to tell you. We can have two sets of values. If one set of value, if you compute R, again if you are making some changes for the x variables and y variables at a uniform rate, then you calculate the R for the new series, then also the value of R will be the same. So you can simplify the calculations. If the numbers are too big, you can divide, you can subtract, you can multiply. So you can reduce it into small values and you can do the computation. So you can simplify the computations. That is the meaning of coefficient of correlation coefficient is independent of change of scale and origin. Change of scale is dividing or multiplying each value of x and y by a constant value. Then after making the changes, correlation coefficient for the new set and the old set will be the same. So this is an important property, and when we will do the problems, it will be more clear. So the first one, find Pearsonian correlation coefficient for the following data. Values of x, 300, 350, 400, 450, 500, 550, 600, 650 and 700. See, the increase is 50 throughout. Similarly, for y series, 800, 900, 1000, 1100, 1200, 1300, 1400, 1500 and 1600. Now, if we divide the values, x series values are divided by 50. Y series values are increasing by 100. So, y series values are divided by 100. So, this will simplify the calculations. So, we are getting the new set of values and x values are there and y values are there. We are going to do the computation by computing from the actual mean. So, to calculate the mean of x series. So, the total is 90 and divided by 9. 9 values are there. So, you will get the mean as 10. Now, you have to take the deviations. That is the small x. Values are there. Then, you have to take the square of those values. 16, 9, 4, 1, 0, 1, 4, 9, 16. Total is 60. Similarly, for y series, you have to calculate the mean and then the mean you will get as 12. So, you have to take the deviations, that is the small y. Then you have to take the square of those values, that is 16, 9, 4, 1, 0, 1, 4, 9, 16. Total is 60. Similarly, you have to calculate xy, that is deviation of x into deviation of y, small x into small y. 16, 9, 4, 1, 0, 1, 4, 9, 16. Total is 60. Now, you have to substitute the values in the equation. You know that R is computed as sigma xy divided by root of sigma x squared into sigma y squared. When we are substituting the values, R is equal to 60 divided by root of 60 into 60. That is equal to plus 1. That meaning perfect positive correlation between x and y variables. If one variable is increasing, the other variable is also increasing, or vice versa. So we have seen that x series values are increasing at 50 and y series values are increasing at 100. Perfect correlation, perfect positive correlation. That is the interpretation. We will see one more problem, that is compare correlation coefficient between the corresponding values of x and y from the following data. So this is one set, that is values of x 2, 4, 5, 6, 8 and 11. Values of y 18, 12, 10, 8, 7 and 5. So we have to calculate R for these values and then they are asking some conversion for the data, that is multiply each x value in the table by 2 and add 6. Multiply each y value in the table by 3 and subtract 15. Find the correlation coefficient between two new sets of values. Explain why do you or do not obtain the same results as that of the first question. So that is two sets of values we are going to compute R. Now, I have explained that values of x and you have to take the mean. Mean you are getting 6. So you have to take the deviations that we are representing as small x. Then you have to take the square of those values. 16, 4, 1, 0, 4, 25. Total is 50. Similarly, for y series, the mean is 10. Take deviations 8, 2, 0, minus 2, minus 3, minus 5. Deviations, when you are taking deviations from actual mean, the final value will be always 0. Now you take the square of those values. 64, 4, 0, 4, 9, 25 and 106. Similarly, multiply x into y. Minus 32, minus 4, 0, 0, minus 6, minus 25, total is 67. Now we have to substitute the values in the equation. So already mean of x series is 6 and mean of y series is 10. Now you have to calculate r, that is equal to sigma xy divided by root of sigma x squared into sigma y square, that is minus 61 divided by root of 50 into 106, that is equal to minus 0.9203. So this is what we are going to establish. This is the computed value. When you compute the correlation coefficient for the converted series also, R should be the same value, minus 0.9203. That meaning very high negative correlation. I told you when we are interpreting the value, if you are getting value above or close to 9 or above 9, when we say that very high negative correlation, that means variables are moving in the opposite direction. If one variable is increasing, other variable is decreasing, or vice versa. That is the interpretation. Now we will see the computation for the new set of values, that is converted values. So x series values are there and y series values are there. So mean of x for the new series is 18 and mean for y is 15. Take the deviations and take the square of the deviations. So x square values 64, 16, 4, 0, 16, 100. Total is 200. And y deviations are 24, 6, 0, minus 6, minus 9, minus 15. Deviation total will be always 0. When you are taking deviations from the actual mean, the total will be always 0. Square of the deviations 576, 36, 0, 36, 81, 225. Total is 954. X into y, minus 192, minus 24, 0, 0, minus 36, minus 150. Total is minus 402. Now, you have to obtain the R for these values. So, first I have explained how we got the values of x for the new series. That is 2 into 2 plus 6. That is why we are getting the first value as 10. For y series, 18 into 3 minus 15. That is equal to 39. This is what you are asked to do in the problem, to convert the series. So, mean for x series is 18, that is total of x values divided by number of values. N denotes number of observations. So 108 divided by 6, 18 is the mean for new series, and y bar or the y series mean is 15, that is 90 divided by 6. Now we have to substitute the values in the equation. Correlation coefficient is calculated using the equation sigma xy divided by root of sigma x square into sigma y square. Then when we substitute the values in the equation, we get R is equal to minus 402 divided by root of 200 into 954. That is equal to minus 0.9203. So the first set of values and the second set of values, R value is same. That meaning it's very high negative correlation. Variables are moving in the opposite directions. That is, one variable is increasing, other variable is decreasing, or vice versa. Then they ask the reason also why the computed values are same. We can establish that computed values for the first set of values and the second set of values will be same. The reason is R is independent of change of origin and scale. So this is what I want to explain in this module. Thank you.